Okay, so this is a supplement to the test review. Previously, this first test has included inverse trig functions, and I decided not to cover that in this test. So I'm adding one additional problem. So I'm going to talk about that. It's basically a right triangle problem where you're given 2 out of the 3 sides, and you need to calculate the length of the third side, as well as all of the trigonometric function values. So in this case, I've given the hypotenuse and one of the sides. So we can call this third side x if you want to. Just assign it some variable. So we have x squared plus 8 squared is equal to 11 squared. X squared plus 64 is equal to 121. X squared equals, so we take 121 minus 64, and that's 57, which is not a perfect square, so we're going to end up with a square root. So we get x equals the square root of 57. Now mathematically you would get plus or minus the square root of 57, but because we're dealing with lengths which are positive, it's the positive square root. So we can go ahead and put that in there. And now to do the trig functions, we just have to remember what the definitions are. So we got sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. Now all of the other trig functions are reciprocals. So the reciprocal of the sine is the cosecant. So that's hypotenuse over opposite. The secant is 1 over the cosine, which is hypotenuse, so it's hypotenuse over adjacent. And the cotangent of theta is the reciprocal of the tangent of theta, so we have adjacent over opposite. So now we just have to plug the numbers in off the diagram. So this is O, this is H, this is A. So the sine is going to be 8 divided by 11. Now we can't simplify that because there's no common factor. Adjacent over hypotenuse, so that's going to be the square root of 57 over 11. And the tangent is going to be 8 divided by the square root of 57. Now this one's fine because the square root's in the numerator. What we have to do here is we have to multiply by the square root of 57 in both the numerator and the denominator. What that does is just gives you this constant times the square root of 57, and the square root of 57 times the square root of 57 is 57. So I need to see this form. Okay, now the cosecant is hypotenuse over opposite. So that is 11 over 8, which is the reciprocal of 8 over 11. The secant is going to be hypotenuse over opposite. Hypotenuse, is that right? Oh, no, I did that one wrong. No, I got it right here. Hypotenuse of adjacent, yeah. So hypotenuse, which is 11, divided by the adjacent, which is the square root of 57. Again, I need to multiply the numerator by the square root of 57 and the denominator by the square root of 57. And then finally, the cotangent, the adjacent side is the square root of 57. The opposite is 8. And you can see if we go back up here to the tangent, if I just take the reciprocal of that, I'll get that. But I don't have to do anything additionally because it already has a square root in the numerator. So the only thing that you would have different here is, I could give you the two sides and you have to calculate the hypotenuse. Now I'm not going to go through the whole process, but I'm just going to set it up just to show you what you would do in case you had that scenario. I'll still call this angle theta. This is still a 90-degree angle. Let's say this is 7 and this is, 8. Let's call this y. So Pythagoras says 7 squared plus y squared equals 8 squared. Well, let's multiply it out. And then you subtract 49 from both sides, which will give you 15. Y squared is 15. So y would be equal to the square root of 15. So you can go ahead and write that up here. Y equals the square root of 15. And then you just, again, this would be opposite, this would be adjacent, this would be hypotenuse. Okay, so that's it.